Hello and welcome back. These would be the notes for Chapter 7, Section 3, Solving Systems by Adding or Subtracting. There is a PDF available if you'd like to print it out and follow along. Solving systems by adding or subtracting. Now, the adding or subtracting is actually got another name. It's also called the elimination method. So you might hear me say adding or subtracting, or you might hear me say using elimination. Here are the steps. We add or subtract the equations to eliminate one of the variables. Step 2, we solve the resulting equation for the other variable that's still in the problem. And step 3, we will substitute that answer into one of the original equations and solve for that unknown variable that was eliminated to start with in step 1. Example 1, we've got two equations here, so it means we have a system of equations. They both have an x, they both have a y. But what you'll notice here is on the y, they both have a coefficient of 3. The difference is one is positive and one is negative. So the question is, how do you get a positive 3 and a negative 3 to cancel each other out? Well, the answer is we add them together. So we put parentheses around the second one, we put a plus sign on the outside, and now we add them vertically. So 4x plus negative 2x gives you a 2x. Well, negative 3 plus a 3 cancel out of the problem. That's really 0y, and 0 times y is just 0. Bring down your equal sign, and then we do a 5 plus negative 7, and that ends up giving us a negative 2. Now we have only one variable left in the problem. Solve for x, divide both sides by 2, and x equals negative 1. But remember, this is a system of equations which requires two answers, an x and a y. I've calculated the x value, so how do I calculate the y value? Well, you have to go back to one of your original equations, and it doesn't matter which one, whichever one looks easier, and substitute negative 1 in place of x. Now I'm going to substitute it into this one right here. So I have a negative 2 times the negative 1, remember that was the x value coming in, plus 3y equals negative 7. This calculation is a 2 plus 3y is equal to negative 7. I'm going to subtract 2 from both sides, so 3y is going to equal negative 9. Divide both sides by 3, and y equals negative 3. And there's my solution. Negative 1, negative 3 is the solution to this system. Next example, we'll see that the x's have a similar coefficient. In fact, they have exactly the same coefficient. So how do you get two positives to cancel out? Well, quite simply, you will subtract. And here's where it's very critical. We're going to put a parentheses there and put a negative or minus sign on the outside, which means everything inside the parentheses is really the opposite of what you see. So what we have here is 7 minus 7, which is 0x, that cancels out. Negative 2 minus a negative 3, well, that's really plus 3. So negative 2 plus 3 gives you 1y, and that's equal to 5 minus 4, which leaves you with 1. So in this case, half of our solution of x and y has a value of 1. So how do we go back and solve for x? Pick one of the equations to substitute y in for. It doesn't matter which one. I'll choose the top one. So I have 7x minus 2 times the 1 for y is equal to 5. 7x minus 2 is equal to 5. 7x is equal to 7, x equals 1. So the solution to this system was 1, 1. Example 3. You'll notice that the y's have a coefficient of 5. The only problem is they're not lined up. So how do we fix that? Well, we have to rewrite one of the equations, or sometimes we have to rewrite both. I'm going to rewrite the bottom one and bring the x over so that the y's will line up. So the top one is going to be unaltered, so it's going to be 2x plus 5y equals 12. This bottom one, I'm going to move the x over this way, which will make it a negative 4x, which bumps my y over underneath the other one, equals, and I still had a positive 6 there. All right, so I've got a coefficient of positive 5 for both y's, so how do you get positives to cancel each other out? Well, we have to subtract them. So what we get with our x's is a 2x minus a negative 4x, which actually gives us positive 6x. 5y minus 5y cancels out. Bring down your equal sign. And 12 minus 6 leaves you with 6, and our x value ends up equaling 1. But this is a system of equations, therefore we have only half of our solution. So we put an x value of 1 there in place of x. Now to solve for the y, we can go back to one of the original equations. I'm going to choose this equation right here and substitute a 1 in place of x. So where x was, I put a 1 plus 6. So 5y equals 4 plus 6. 5y equals 10. Y then would equal 2. So the solution to our system is 1 for x, 2 for y. Example 4, word problem. During a kayaking trip, a kayaker travels 12 miles upstream. That's against the current. 12 miles downstream, that's with the current, and it's shown in the picture. The speed of the current remained constant during the trip. The question, find the average speed of the kayak and the current in still water. So the question part is telling us what our variables are going to represent. I've got a K for the kayak, and I've got a C for the current, and the K is going to represent the speed of the kayak, and the C is going to represent the speed of the current. Well, I know that I have a speed for the kayak and a speed for the current, so when I'm going upstream, as they said here, that's against the current, my speed is going to be reduced by the speed of the current. So the kayak speed upstream is reduced by C. Well, what we have is a speed number plus a speed number. Well, that's got to equal more speed. So where does the other speed number come from? And actually, in this case, this was a minus. Let me go back and change that. Speed minus speed equals average speed. Well, we have a distance of 12 miles, and they told us in the picture that it took 3 hours to do that. Well, distance is equal to rate times time, and the rate is what I'm looking for. So how do I calculate rate? Well, we take distance and we divide it by time. So 12 miles over 3 hours gives us a rate of 4 miles per hour. So our upstream speed was only 4 miles per hour. When we go downstream, we are going with the current. So that is going to be kayak speed plus however fast the current is pushing us. The question is, what was the average downstream speed? Well, we're still going the same 12 miles as we did before, but now it's only taking us 2 hours to do it. So that distance of 12 divided by 2 gives us a speed of 6. Now they are asking for both the kayak speed and the current speed, so we have to solve for both K and C. K minus C and K plus C. I like the plus and the minus, so I'm going to cancel out the C's, and the way we get them to cancel out is to add. So K plus K gives us 2K. The C, the positive C and the negative C, when you add them together, cancel out, and the 4 plus 6 ends up equaling 10. So K is going to equal 5 when you take 10 divided by 2. So the K, which is the kayak speed in still water, is 5. So how do we calculate the speed of the current? Well, we can go back and take K, which was 5, subtract the current, and that's going to equal 4, and now solve for the current. So negative C equals negative 1, multiply both sides by negative 1, the current speed should equal 1. So a kayak speed of 5 in still water, and the current is actually going against or with by 1 miles per hour. Example 5, geometry problem. This looks like a perimeter question. It says the rectangle has a perimeter of 14 feet. Well, they told that to us right here in the middle. Perimeter equals 14. And twice its length is equal to 1 less than 4 times its width. So they're kind of telling us right here, twice its length is, that's an equal sign. So length times 2 equals, what does it equal? 1 less than 4 times its width. So 4 times its width minus 1. And that's the equation they're telling us there. They want us to write and solve a system of equations to find the length and width. Well, that's only one equation. So where does the other equation come from? Well, they did tell us that the perimeter was 14. Well, the perimeter formula is 2W plus 2L is equal to perimeter, and they told us that the perimeter was 14, so I can actually substitute P with 14. So 2W plus 2L. Okay, so we have these two equations here. The only problem is that the L and the W's are not lined up. So what I have to do is rewrite this equation. And which way am I going to write it? I'm going to bring the 1 this way and the 2L that way. So when I do that, my 1 becomes a positive 1 equals 4W didn't move, so it stays the same. And when I bring the 2L over to the right side, I end up with a minus 2L. So now I can actually rewrite my equations so they're lined up. So I have 14 is equal to 2W plus 2L. And I have another equation of 1 is equal to 4W minus 2L. So you see we have coefficients of 2 on the L, but they're opposite signs. So how do you get opposite signs to cancel? You'll simply add them together. So add them vertically. 14 plus 1 gives you 15. Bring down your equal sign. 2 plus 4 gives you 6W. And 2L plus a negative 2L will give you a 0L, which is 0. So there's no more L's in the problem. And over here on this other side, we have 15 equals 6W. So divide by 6 on both sides. And W ends up equaling 2.5. So we know the width. Are they asking for both? Find the width and the length. Yes, so we've got the width already. So we know that W is equal to 2.5. So how do we find the length? We go back to one of our equations. Let's say we go back to this equation right here, and we substitute a 2.5 in place of W and solve for L. So 1 is equal to 4 times 2.5 minus 2L, and now we solve for L. So 2.5 times 4 gives us 10, so 1 equals 10 minus 2L. Subtract 10 from both sides. We end up with a negative 9 is equal to negative 2L. Divide both sides by a negative 2, so negative 9 divided by negative 2 gives us a positive 4.5. So we've got one answer, a width of 2.5, and the other answer is a length of 4.5.